Okay, so going on with our 5, 6. We just finished highlighting and talking about how the information that we were given in number 5 matched us up to do a non-included side AAS. I'm just picking up my video, you guys, from the last one. I stopped it off. And then when we went on to number 6, though, and we tried to match it up, we realized that they wanted us to pair up L and R together, but those angles didn't correspond to each other or match, so we couldn't put a theorem to prove their congruences. I know I can prove these congruents because it matches up with AAS, but on this one I couldn't do anything. Let's turn it over and take a look at the 2 proofs that we got in here. Now, in the proof for number 7, they're actually telling us straight up that we need to be doing an ASA congruence proof. They say use ASA congruence. So I guess we got to start looking at how are we going to piece together this ASA. I'm going to grab a yellow and highlight my first A, and I'm just going to go down here to, oh no, I'm getting ahead of myself already. Bisecting. AC bisects angle DAB and angle DCB. All right, so let me use my pencil for this one. I don't think I'm ready to highlight anything. AC, this side here, bisects DAB. Okay, so that means by definition it splits it in half. If AC bisects DAB, that means these 2 angles at A then are going to be congruent to each other. I'm over on 152. And they also say that it bisects DCB. Beautiful. So here at C, we've got a pair of congruent angles because AC is the bisector. Now, I'm comfortable with grabbing my colors now. There's a pair of angles. There's my yellow in my ASA. I'm gonna go take this down into my proof. They gave me so that's the bisecting of this DAB is coming for the yellows. I'm gonna have to interpret that. And then my other angle pair that going on at C, that came from here, I'm gonna have to interpret that. So there's my AA, and I think the only side congruence I'm gonna be able to deal with is this AC is AC. There's my ASA right there. AC is AC, I'm gonna have to pull reflexive in there. I'm gonna have to pull reflexive in there to get that middle side. My middle side, or my included side. So I got some, I need to interpret this given twice, how it's the bisector of DAB, and then I gotta interpret it as the bisector of DCB to get at those congruent angles. And then I gotta make a statement about my AC being AC, that reflexive idea that just name that side for both triangles. So my first statement, let's get that given out there. AC bisects. Now I can state both angles, but we'll just break it down in 2 other steps. Angle DAB and angle DCB. Oh, that's not the second reason, that's the first. That guy is given. Now, I want to interpret that given. I'm actually going to organize this ASA. I'm going to make my number 2, that first pair of angles. I'm going to make my number 3. I'm going to speak to that pair of reflexive sides. And I'm going to make my number 4, that second pair of angles where I interpret the given. So my first pair of angles was a bisector. By definition of angle bisector, I came and said that DAC, my yellow, angle DAC is congruent to BAC. Angle DAC congruent to angle BAC. That's what I had highlighted in yellow, and that was an interpretation of my given. That was the interpretation of this DAB in the given. So that split my yellow angles into congruent pieces. I want to put the side length next, so I'm just going to make that AC is AC statement. The it is what it is the reflexive. I noticed on quizzes a lot of you guys are writing reflective. It seems like that, but it's reflexive. Stick an X in there. I didn't mark it wrong or anything. Huh?
What quiz do we have to put that in?
You took a quiz last week. Oh. No, a couple people do. That's funny. No, a couple people on the quiz actually did like some proofs to the explain rather than just using color coding. Which was, yeah, if you did not write it all out like that, if I remember right, that wasn't necessary, but I just know I saw a few people using it to talk about something. Now, my fourth step then is going to be this other angle interpretation of that. So what I did in blue, that's going to be what I did in blue, how I split that DCB angle. So when I split the DCB angle, I got DCA, angle DCA, congruent to BCA, angle BCA. And that actually is still my definition of angle bisector, because that first given broke up two different angles. Now with all those reasons over there, the fact of the matter is I've got my entire ASA. Bless you. They told us ASA too. I got my entire ASA mapped out. I can come down here with my final reason is the ASA. And my final statement, since I've shown every part, is going to be that those two triangles ABC and ADC are congruent to each other. Now with this, I'm going to freeze this up. In class, I'm going to go back for people watching the video. I just want to put those numbers 5 and 6 back in front of you just for the color coding and whatnot. We're going to go on. We got one more proof. One more proof we're going to look at. And, you know, it's some might argue it's a little better than some of the algebra stuff. She says no. What kind of a figure, you guys, do we have in number 8? What kind of a figure are we in? What are our triangles inscribed in? What kind of a figure are we looking at here in 8? That's circular figure, yeah. This one is telling us they want us to use AAS. And we have a circular figure, so I think that one of the things that we can say is we can speak to side lengths. When we have a circular figure, we can speak to side lengths. And O being the center of the circle is going to tell me then that any side from O is going to be congruent. Any side from O to the circumference of the circle, O to N, O to Q, O to P, O to M. These guys are all radii, so they would all be congruent to each other. They want us to do angle, angle, side here. Well, what kind of triangles did we just make, you guys? If these two sides of each of these triangles are congruent, what kind of triangles are these? These guys must be isosceles. And if they want us to use base angles theorem, I think one of the things that we need to do then, since these both are isosceles triangles, isotries, I think we're going to be able to force in some information about these base angles because, again, they tell us they want us to do AAS. I think I'm going to be able to say N and Q are the same because they're base angles. I'm drawing in yellow on Q. I'm going to be able to match up N and Q. I just got to talk about how they're base angles. And then I'm also going to go and take my blue on M and, oh, I'm just going to put blue there, not double marks, on M and P. Because since these triangles are both isosceles with the same size legs, those base angles are all going to be congruent to each other. So this one's going to be a little interesting to you to how do we go and talk about all of this? Because we've got to pull an AAS into here. So I'm going to state my given first. And then when I state the given, O is the center of the circle. And that is a given. You know what? I'm going to even throw and I'm going to throw this and angle N is congruent to angle P. We can refer back to it then. Now that it's there stated as the given, we can refer back to it. Now the first part of this given statement gets at our side lengths. So I'm going to kind of take my red over that. That's what I had gone in. This first part gets at the side lengths. So what I'm going to throw into that one is definition of radius. So that can take me to go on and say ON. All these radii are congruent. ON, OQ. Oops. OQ. ON, OQ. Congruent to OM. And that's also congruent to OP. So by the definition of the radius of a circle, if we're given a circle, all the radii are the same. My third reason is going to be the base angles theorem. I think we can cover, yeah, we can cover both A's here, both angle pairs. We can cover both angle pairs in statement 3. Because by the base angles theorem, we can go around and say N, Q, M, and P are all the same. Angle N congruent to angle M, congruent to angle P, which is congruent to angle Q. Yeah, so my third step just showed all those angles are the same. And realistically, you guys, we have 2 non-included sides. We've got AASS because we've got both non-included sides. It was a little bit more than we even needed. We had both pairs of non-included sides congruent. They wanted us to finish with AAS. So my last statement then is going to be my triangle MNO is congruent to triangle PQO. Now, as we work through these, I know they're kind of tricky, but hopefully just the color coding and the way that I'm coming off to the side and kind of stating through each piece, hopefully it's just getting better as you, like, it's getting easier as you try.